Today we are going to continue our adventure with polynomials. At this point we've introduced what a polynomial is and some basic polynomial vocabulary, and yesterday we started talking about calculating with polynomials. So yesterday's lesson dealt with adding and subtracting polynomials. The next two lessons, today's lesson and tomorrow's lesson, are going to deal with multiplying polynomials. There's a lot to say about multiplying polynomials, which is why it's spread over two lessons. So today what we're going to work with is actually not multiplying a polynomial by a polynomial. We're going to talk about multiplying a polynomial by a monomial, because that is the first step in multiplying a polynomial by a polynomial, which you're going to talk about tomorrow. One step at a time. So today we're going to focus on a polynomial times a monomial. So you can kind of see in this first example, when we get to it in just a second, there's our polynomial and there's our monomial that we're multiplying it by. Multiplying a polynomial by a monomial is actually not that bad. It basically is just a giant distributive property problem with a little bit of exponent rules thrown in. So to multiply a polynomial by a monomial, the trick is to use the distributive property. So if we're going to use the distributive property here, you can multiply this outside number by however many terms are inside the parentheses. So you guys are used to doing the distributive property with problems that look something like this, where you have a binomial times a monomial, now that we know what those are actually called. So in that case, you would end up multiplying twice. But you could put more things in the parentheses. You would just have to keep multiplying until everything in the parentheses gets multiplied. So that's what we have going on here. So we have 3 terms in the parentheses. So that just means that each of those 3 terms is going to get multiplied by the 6y sitting outside the parentheses. So we're just going to have to multiply 3 times because we have 3 terms in there. So it's kind of like a big distributive property problem. So I'm going to write out the multiplying that's going to happen first, and then we'll go through and we'll actually clean it up so that you guys can see what happens in there. So this first one, we're going to end up doing 6y times 4y squared. And then the second one, we're going to end up doing 6y times negative 9y. Well, we know that that's going to be a negative because a positive times a negative is a negative. So minus for negative, 6y times 9y. And then the last one, 6y times 7, and it's a minus or a negative 7 again. So we know that's going to be a negative because a positive and a negative is a negative. So minus or negative 6 times 7. So I haven't actually done any of the multiplying yet, but now we're going to go and clean it up. So this is the part where a minute ago I mentioned that multiplying a polynomial by a monomial is like distributive property with a little bit of exponent rules tossed in. So this is where we're going to throw in a little bit of exponent rules. When we learn to multiply monomials, multiplying monomials involves all of those exponent rules from the first half of the chapter. So we're going to use those a little bit to clean up each of these terms. So if we go through term by term, so we can do the 6 times the 4, so that's 24. And we know that y times y squared, that's our exponent rule where we can add the exponents. So y to the power of 1 times y to the power of 2. So if we add the exponents, that is going to give us y to the power of 3. So that cleans up the first term. Minus, if we move on to the second term, we can go ahead and do our multiplication. So we can go ahead and multiply the 6 times 9. So that gives us 54. And then y times y, those can go together and those make y squared. And then the last part, we just have constant terms. Those are just regular old numbers, so we can go ahead and multiply those. So 6 times 7 is 42. So use your distributive property, multiply it out, but then you might have to use a little bit of exponent rules to get things cleaned up. So these are not like terms. We have a constant term, a y squared, and a y to the power of 3. So none of those are things we can combine, which means that this is as far as we can go. So this polynomial that we ended up with is our final answer for what we get when we multiply there. We can take that and to start putting some pieces together, to start building some layers on for you guys. We can take what we just did in this example, really a giant distributive property problem, and we can combine it with what you were doing yesterday with adding and subtracting polynomials. So if we do that, you get something kind of like the second example. So you can see that we've got two polynomials that we're subtracting, so that's like yesterday, but we also have multiplying, which is what we were just talking about today. So a little bit of what we were just doing combined with yesterday. This is completely doable. The trick with it is you just need to follow order of operations. So if I've got some multiplying going on with my polynomials and then some subtracting, order of operations tells me that I would do the multiplying first. So I need to figure out what 3 times 2t squared minus 4t minus 15 is. I need to do that multiplying. And then I also need to do the multiplying over here according to order of operations. Well, we were just talking about how to multiply polynomials. Giant distributive property problem. Since we have that happening in two different places, we have it happening once right here and then again once right there. We're just going to go through that process 2 times. So let's go ahead and do that first step. So giant distributive property problem. And this time I'm going to go ahead and write down the answer when it's multiplied out. So before we kind of wrote out the problem and then we cleaned it up, a lot of times most people will just skip from here straight to here and they'll kind of multiply as they're writing it out. The only reason I wrote it out is so that you could kind of see where your exponent rules are happening in there. So 3 times 2t squared. So that's going to end up being 6t squared. And 3 times negative 4t is negative 12t. And 3 times negative 15 is negative 30. Now, yesterday, remember when we said we're adding and subtracting polynomials, we have to distribute the subtraction, distribute the negative. So since we have to distribute the subtraction and we're multiplying, this whole thing we can just distribute at once. So that takes care of the 6t, and it takes care of the fact that we have to distribute the subtraction in order to subtract the polynomial. That was what we talked about yesterday, how to subtract polynomials. So we're going to kind of do both things at once. We're going to distribute the subtraction to take care of the subtracting part, and we're going to multiply by the 6t. So if I do that, minus 6t or negative 6t times 5t, so I'm going to end up subtracting or minus 30t squared. And then the second one, a negative and a positive makes a negative. 6 times 2, so negative 12t. Now we can go through, and once we've distributed the subtraction, we can go through and look for things we can combine. So now we can go through and we can look for like terms. So there are a couple of like terms right there that we could put together in just a second. And then we also have a couple of like terms right here that we could put together in just a second. And then we've got this negative 30. That negative 30 doesn't have anything he's going to combine with, so he's just going to kind of hang out over here at the end of the problem. So if we combine things, so 6t squared and negative 30t squared, or if you want to think subtraction, 6t squared minus 30t squared, 6 minus 30 is negative 24. So that's going to be negative 24t squared. And notice that I put the thing with the highest degree first because we're also trying to write this in standard form so that our answer is all nicely formatted. So minus 12t and minus 30t, you can think of those both as negatives. So negative 12 and negative 30. So that works out to negative 42. So minus 42t. We've got everything put together. So that is our final answer right there. Negative 24t squared minus 42t minus 30. So that problem looked kind of long, like it had a lot going on, but it's really not too bad. It's just putting together an idea from yesterday with our idea from today. Now, we are going to talk about one more thing today, and it has to do with this problem that we just did. So basically using what you've done so far. So adding, subtracting polynomials, and multiplying a polynomial by a monomial. So at the end of your notes for today, you have this very long looking equation. But it's actually not so bad as long as you know the process to go through. So if you look in this equation, we've got some polynomials being multiplied by some monomials in different places here. So we're going to have to use the things we've been talking about. We can work with this equation just like we would solve any other equation. So to do a quick recap of the basic process for solving an equation, basic solving equation process is we don't want parentheses. We need to get those out of the way. So we're going to start. The very first thing is distribute to get rid of parentheses. And then we're going to look for things we could put together. Combine like terms. And that is going to clean your equation up. Going through those last two steps, that's going to do a lot for your equation. The last thing you want to do, which is going to get your equation down to a point where you could probably see pretty easily what to do from there, would be to look for variables on both sides. Because if we have variables on both sides, then we should be doing some properties of equality, some canceling to get rid of some things. Both sides. So if we track through those steps with this rather long looking equation. So the very first step, step 1, distribute. We have two places where we have parentheses, so we can distribute right here. So b times 12 is 12b. b times b is b squared. And then that minus 7 is just hanging out there because that wasn't in the parentheses. Equals, we've got this 2b sitting there. Again, that's just going to hang out there because there's no parentheses there. But we do have parentheses here. So b times negative 4 is negative 4b, which negative and minus kind of do the same thing in algebra. So minus 4b. And then b times b is b squared. So that's our first step. We just got rid of the parentheses. Second step. Now we want to look and see if there's any like terms that we can combine. On the left side of the equation, there's not, because we have a b squared, and no variable. None of those are like terms. We can't put them together. On the right side of the equation, we do have a couple of things we could put together, though, right here. Those both have the same variables, so we can go ahead and combine those, and that will clean things up for us a little bit. So we're going to rewrite the left side since we're not touching that, but we are going to clean up the right side. 2b minus 4b, 2 minus 4 is negative 2. So negative 2b plus b squared. Okay. So already this equation is looking a little shorter and a little less complicated than it was before. So now we're going to come through and we're going to look for variables on both sides. So we want to look and see if we have things that are on the same side of the equation, and if we have the same type of variable, so like terms basically, but on opposite sides of the equation, then we want to try and cancel some things out so that we don't have it sitting in both places. So remember, if your like terms are on opposite sides of the equation, you cannot just smash them together. So, sorry about that. This equal sign is kind of like a wall. Things cannot magically pass through the wall. But we can use our properties of equality to move things around. So right off the bat, I see that I have some b squareds here and some b squareds here, and I don't want that in two different places. So what I'm going to do to take care of that is I am going to subtract one of these b squareds, and that's going to cancel that out. But whatever I do on one side of the equation, I have to do on the other side of the equation. And I just realized that I added a square where there shouldn't be one. So this is actually going to go over here. So b squared, basically we have a b squared on both sides of the equation. So we can just take that off. We're taking the same amount off of both sides of the equation. So if we do that, then that leaves us with the 12b minus 7. And on the other side, we have negative 2b. So we should kind of keep looping through that process and keep looking for like terms on both sides until we don't have any more. So if we kind of go another round with that, well, these both have a b, so I can deal with that. Now in this case, a lot of people would go for the negative 2b, canceling that because they don't like negatives. But if I do that, I'm not going to have anything left on the right side of my equation. So it would actually make sense to cancel the 12b so that I still have something on both sides to work with. So I'm going to cancel this 12b with a negative because it's positive. Negative 7. Negative 2b minus 12b is negative 14b. And oh, look, my big long polynomial equation just turned into a happy one-step equation. So hopefully from here you know exactly what you should do, and that is to divide both sides by negative 14. Now in this case, this doesn't work out to a whole number, it works out to a fraction, but we know a negative divided by a negative is a positive, so we know our final answer is going to be positive. If you wanted to leave that in fraction form, you could just reduce that. 7 over 14 is 1/2, so b is 1/2. So it really is a solving equations problem, kind of like ones that we've done earlier this year. We've just got some polynomials in the mix. In this case, and in the problems that you're going to be working on today, the polynomials will cancel out when you're working on solving the equation. So there is that, what if situation. What if the b squareds don't cancel out and I still have a b squared in there? That gets into something called a quadratic. And we are going to do an entire chapter on that. That idea of, well, what if the b squareds don't cancel out? How do I solve the equation? We're going to do a full chapter on that before we get to the end of the year, but that's not in this chapter. It is its own chapter all by itself. There's that much that we could say about that. So that would be, as I like to tell you guys, there's always a twist. That would be a big, giant, full chapter twist. But we're not there yet, so you don't have to worry about that today. All of today's equations should work out similar to the example problem that we just looked at. So at this point, your notes outline should be completed so that you have a nice worked out example of each of the types of problems that you are going to practice today. If you missed any parts of your notes, you can go back and rewatch the video and fill it in. If you printed out your notes outline for today, make sure that you put that in your notebook. Also, don't forget to add lesson 7.6, multiplying a polynomial by a monomial, into your table of contents in your math notebook. And then when you're ready, you can go ahead and work